Oh, hi! Nice of you to join me. I'm building a Grindbox for rollerblading, for sliding. I thought I'd bring you along on this little adventure. I'm using a metal rail, metal coping. Most people use PVC for this. I've had a really hard time finding a PVC that's strong enough. It's usually very thin, it flexes, it doesn't slide well, eventually it shatters and breaks and it sucks. So for the first time I'm using metal coping for building something like this. I can't weld and I don't do metal work, so welding is out. And so how else do you fix this onto a box? Well, I'm using the same technique, so a screw through the middle. And my number one question when I thought about doing this was, can you actually drill through a metal rail? Do you need special equipment? This is quite thick metal. It's like a couple of millimeters thick. So, but the answer is yes, and I'll show you how that works. So remember, safety first. You want goggles because you don't want metal shards in your eyes, however unlikely that is. And I'm wearing hearing protection because the sounds are not very nice. And this is a cheapo drill. It's electric, obviously. I'm using it in the drill mode. Do not use the hammer mode. I think the hammer mode is for special stuff. So just make sure you use the drill mode. If you have a drill and a hammer mode, use the drill mode. The drill bit I'm using is, I think it's about 4.5 millimeters. It's kind of a multi-purpose drill bit. I'll cut to a section now where I talk a bit about drill bits. Right, drill bits. I've got quite a lot. I inherited all the tools from my grandfather's workshop, so I have a lot of old drill bits. Some of them are a little bit rusty, but they work. I started though with this set from Bosch that I had. Now these in the middle here, these are apparently titanium coated, also Google tells me, and they are specifically made for drilling in hard metals like steel. I don't know if I've used these incorrectly. I've had this set for years when I was young and dumb. Now I'm just dumb. But I don't know if I've used these incorrectly in the past and they are just not sharp anymore. But drilling a hole with these took about 20 minutes to get through the coping here. You can see the thickness here. So it's quite a substantial amount of metal to get through. And then I switched to these general purpose. The same place on the internet told me that if you have black drill bits, I think they're cobalt or something, and they are even more meant for drilling through hard metals than the titanium lined ones. So I don't know, I don't think that's true. I don't think these are cobalt bits. You can see on the edge of the screw there that it might just be a black coating, I think. But either way, these are just some bits I found in the box over there. They work much better. So this is the kind of bit I've been using to, if it will focus, sorry, phones, I should film with a proper camera. These are the type of bits, focus, I've been using to drill through metal. Maybe it's easier to see on the big ones. So you'll see that the tip is not very aggressive, and it's got these cutting points there, which are the most important part. Maybe I'll switch camera. Focus. Yes, that's what I wanted. Okay, so now you can see some detail on this drill bit. And obviously it spins in that direction to drill. And this is the 8.5 mil, so that's the one I've been stepping up to from the smaller 4.5 millimeter. For reference, a wooden, specifically for wood drill bit, usually has more of a spike design. So you see that's a very, very aggressive top. So that will drill wood very nicely for you. you can get that initial push into it. Those spikes will dig into the wood and you'll get through the wood in no time. And then you want a more, like a less aggressive bit for drilling in metals. There's a couple more bit types or drill bit types. Any type of drill bit with a hammerhead on it, like this, that's meant for concrete and stone stonework. So don't use those. You want something like this, and not something like this, because obviously that's not going to do anything on metal. It would just kind of self-destruct if you try to drill metal with that. So that's drill bits. And we're back. So I'm going to be using this. The trick when drilling through metal is go slowly. If you go fast, you will generate a lot of heat, and heat is what makes these drill bits dull. So you want to use a slow speed and like more pressure down. So there's like a really good holding point here, so I can put pressure down onto the drill bit, and then it's got a speed setting on the trigger. So low speed and high pressure. Oh, and before I start drilling, I have used a center punch, which looks like that. A center punch and a hammer, like so, just to make an indent in the metal. I think I've ruined the center punch in the process, but it's done the job it needed to do, and that stops the drill bit from wandering around. When you're drilling on top of a round rail, it likes to do that. So. Okay, and we're through. So that's how you drill through metal, low speed. Try to use the right drill bit. And what I've been doing, I've been starting with this 4.5mm bit, and that's big enough for the screw to pass through. But then for the screw head, which obviously needs to pass through one side of the rail but not the other, I've been using a larger, I think that's an 8.5mm drill bit. So that's drilling through metal to put metal coping on a wooden box. And let's have a look at the box and the construction of that. Okay, so here's my my box. In the past, I've constructed these mostly out of small beams and then put plywood on top. Thanks to some guy on Reddit whose name I'll leave somewhere in the description. He uses actually beams to put this whole box together. So all of these are 45mm in thickness. That's a standard thickness in the construction industry, so it's easy to find that thickness of wood. So this piece is 220 wide and 45 thick. and then it's 2 meters long. And yeah, I know that's maybe short for some people, but I've got a small space here, so this is just a small grind box for a small garage. So 220 wide, 45 thick, and then I've used 195 wide, 45 thick. So you can see how this piece here is 220 wide, so it brings it up to here, and this piece is 195 wide, which brings it up to there. So it's a little bit lower, which gives the top beams something to sit in. One of the big benefits about using 45 millimeter wide beams is that standard scaffold piping is 48 millimeters wide. So you see this pick up this wood. This pipe sits almost perfectly on this beam. There's a slight gap there, you can see, but it creates this perfect seat here for the pipe or the coping to sit in. And then if you want the top of your coping to be level with the top of your box, all you need to do is use like the same width pieces here. That would obviously bring this level up. It would make this piece and this piece the same height, and then you'd get 45 thickness here on top, so that would be level with your rail. So you can adjust the width of this piece to adjust the height of the box. Okay, and just to show you the interior structure of this box, so everything's 45 thick, and these are cut to length to match the width of these two pieces. So just make sure you get a straight edge. I had some difficulty getting a straight edge. To begin with, I was using this jigsaw, which is very easy to use, but it's very difficult to cut straight with in both angles. It's got adjustments to keep it level or not, and I couldn't get that perfect. And then of course, as you're cutting along, it's very difficult to cut a perfectly straight line. I switched to this bad boy, my Metabow, which is that's a spinning disc instead. So because of the length, the effective length of that cutting blade through the wood, it makes it much easier to cut straight. It also had a much more accurate measurement for the angle of the cut, so that was easy to get straight. And then it had this nice hole, that hole there you can look through. Ooh, that hole there you can look through just to keep your cut going straight. So yeah, shout out to my Metabow. It's old because it's made in Western Germany. So that was before the wall came down, I guess. Yeah, what else to say? That's it. That's the construction of the box. These are countersunk screws here. I didn't have the longest screws available, so I countersunk them about halfway into this piece of wood to give them plenty of bite in here. Tip for countersinking: put a piece of tape around your drill bit, and then as it's going down, you see when the drill bit reaches the surface of the wood, you've drilled deep enough. Also keep in mind, if you're going to have this for outdoor use, I've used untreated wood here. This is just raw construction wood. Anywhere where this is going to get wet or damp, you want to use what's it called, pressure. They treat the wood with pressure. It gets into the wood. I don't know what the word is in English, sorry. So yeah, that's my box. Final thing I'm going to do, this one disadvantage of this thing, this construction method, is it is incredibly heavy. Like, I can't move this on my own. I can't lift it fully. So Don't know what I'm doing here, because I'm gonna have to put it down. Put it down on my foot and then pull the foot out the way. Yeah, it's really heavy. Like, it weighs more than I do, especially when you put these the steel coping on it. So that's a disadvantage of this. If you want to have a box that you can lift in and out of your car, move around on your own, this is not the box for you. But it's very stable, very strong. It requires minimal cutting of wood. I actually bought the lengths of wood. They cut them down to 2 meters for me at the woodyard. So I didn't have to cut these myself. I got perfectly straight, even cuts from the woodyard. And the only pieces I had to cut were these. I just had to cut 4 pieces of wood. I had the coping cut for me at the scaffolding place where I bought them. So yeah, minimal cutting, really easy construction, very stable, like few pieces, which is very nice to work with. But yeah, the final thing I'm going to do is drill some big holes here and probably just cut along them with the jigsaw. So I basically get some lifting points. Because as you can see, there's this thing just goes down to the floor. Maybe you could lift by the coping, but that's not what that's designed for. So yeah, I'll make some grab handles or some lifting points, and that's it. I guess I could show you the screws that I'm using. They're over here, or at least one of them. Standard wood screw. So that's what I'm using to attach the coping, and I'm putting that in at an angle. It's going in. I've marked where the beams are, so I put them in at an angle, so they go into the kind of corner here and then into the beam. You can see there's screw holes here, so that's where the beam goes. So one at each beam. There's basically 4 screws there per piece of coping. All right, I talked for much longer than I expected to about this, but I hope it gave you some useful information. And happy blading. Bye.